So the next case will come from Tallinn University of Technology, where Innar is working. And so the case is that a few years ago, Estonia became the first country in the world to have nationwide electromobility infrastructure. And how we try to turn it into a data platform, that's your show now.
Thank you. So welcome. How is everybody? My name is Innar Liiv, and I will tell you about a very interesting project where we analyze the big data of 500 electric cars. So first, a bit about the background of the project. In March 2011, Estonia sold 10 million CO2 emission units to Mitsubishi Corporation to finance its electricity mobility program. In exchange, Ministry of Social Affairs bought 500 Mitsubishi cars, and basically it was one of the largest governmental fleets of electric cars. But decision number one, which is very important, all cars were equipped with a data logger. Decision two, Estonia did not give any foreign entities the access to the raw data. Basically, the data had to be processed and turned into reports, valuable insights, information here in Estonia, which meant that whenever somebody asked that, can you please give us the information, we just said that, tell us what you want, we can do it here, so we won't give the raw information, but we can do all the processing inside Estonia. Now, Mitsubishi Motors was very interested about how their cars are doing in Estonia, so they approached Tallinn Tech. We started a project where the idea was to analyze the raw data and turn it into interesting insights, visualizations, to understand how the cars are doing in Estonia. Basically, to do it in a privacy-preserving manner, in our legal context. And the idea or the reason is that corporations are excellent at factory tests, but real life is something different. So you really need to know or see the living lab or those actual people, how they act in some specific real places with the real context. Decision three, which was done now by the Tallinn University of Technology, was not to do it as a contracted research, but to structure it as what we call a Mectory innovation project, where we involve students to basically deliver the project. We structured the contract in a way that, of course, it had some very specific tasks which we had to do, but we also included an innovation component where the students could basically have all the data, and and we asked them to think about the ways, how can you visualize this data? What could you see from the data? Who would care, about this visualization? What services can you build on that? Not the other way around, but we said that here's the data. What do you see? What can you do with that? There was some questions earlier about, what's the thing with the big data, actually. So I will try to give you, I think, a great example about small data versus big data. Let's have a question of, let's say, how much does a car consume energy at 70 kilometers per hour? The classical approach, the hypothesis-driven, is that let's have the question, let's carry out experiments, let's have a car, some measurement tools, let's pick a road which is basically long enough where we can safely and repeatedly do it and drive the car with 70 kilometers per hour. And let's do it 5, 10, 20, 50, 100 times so that we can get the scientifically reliable answer. Or the data-driven approach is that the cars are already logging the information. And we can be quite sure that over the period, let's say a year or two, there must have been at least thousands or thousands of people who already drove just, by their everyday lives with 70 kilometers per hour. And we have more. Basically, we have more experience and experiments from the real world than you could ever have with some, let's say, classical approach. Plus, we can do it anonymously. We can consider all other kinds of information, like temperature, location, and we can even get new hypotheses, new questions as we go, and we can rerun, we can add the new questions without rerunning the whole experience. Now, in short, the project was then to turn, we got 100 million data points, data rows from Ministry of Social Affairs, who was the owner and who was the owner of the data, and we had to turn it to a final report, to some meaningful results, what can be seen from the data, how the cars are doing, how efficient they are in Estonia and so on, and we used then students and the ideas for that. Now, how did it look like? How did it actually look like? I teach a data mining course or a data science course every year for 50 students. I gave the data, of course, anonymized data, so that they could actually do a brainstorming in teams and figure out and just brainstorm. So you have this data, how can you visualize it? So that you can actually see the patterns emerging, you can see the relationships. How could you do that? So they brainstormed, they provided some solutions, some more solutions. Then we started to, with the graduate students, with pizza, we started to select from the solutions. Then 3 a.m. we started to code these solutions. And when we got great ideas, and we did the same thing 3 years in a row. And when we got the results, then we dressed up, flew to Tokyo, presented it to our partners, and I think even for students, it's a wonderful experience if you can do that. Now, I really want to show some very specific examples of the methods that we used, so that you can actually just have something to take away or think that, how can I use this kind of method for my problems? And I really want to use this metaphor of a park. So think about this picture. It's a park where you have the pre-designed roads, and you have the path where people actually go. But you can do the same thing in digital space. Plus, the pathway is anonymous for all the, the privacy-preserving and data protection fans. Nobody cares that, who stepped on the path, but we see that the people were there. So the first solution, what I always recommend, and what we did, is that we just took the 100 million data points and we put it on an Estonian map, together with some other relevant information. For example, we added the Estonian infrastructure of quick chargers, the charging of the electric cars, and the actual cars. So the blue lines are the cars driving, and where there's more intensive usage, then it will turn into red area. It's a heat map in Estonian, hitomapo in Japanese. And we basically did the same thing for all months, and you can actually see, which ones of them are used. You can, if you see something, you can start to think about, let's say, the infrastructure question, whether we should add some additional here, whether those are not necessary, and so on. Method number one. Method number two, very similar to our Hungarian colleagues' methods in healthcare. So we visualized the driving pattern or the structure of driving pattern for each of those cars. So what we did was that we identified, let's say, the most frequent places where the car went, and the names as home, office, client, shop are just for the example. Our researchers did not know about any actual locations, just that those were the most frequent ones. And the analysis was easy. If they were the frequent locations where the car was going, we added those locations as nodes. We added a line if they were driving from one location to another. And if there was more activity between some locations, we added a thicker line. It's called graph theory. And basically, in the end of the research, you can have for every car, for your predetermined time, either it's 7 days, a week, a year, a month, you can have this one picture which summarizes or tells a story about this car. Basically, what was the structural behavior or driving behavior of this car. This was just one example, but and here are, let's say, 6 examples of 6 different cars. And you can definitely see that there are different things going on. For example, on the top, there's a car servicing different locations. There are some cars who have like 2 headquarters where they are going to other places. And there were cars which over a whole year just drove to, let's say, 5 places. And you can easily see that. And that was 6 cars, but we did it the same thing for 500 cars. And you can imagine that you can have this huge map or this graph, and you can just, as the person who owns the cars, you can just stand at the map and see whether you start to see some patterns, whether there are some cars which you really would like to explore after having, or discover, or have some additional questions if you have this kind of pictures. Of course, we added super many additional information whenever needed, also to the same picture. Method number 3. People often do surveys, so they ask about perceptions, beliefs, feelings, and so on. So we thought that could we actually, not replicate, but could we compare our data with the survey which already exists? So our idea was that we will take a survey, which was, for example, a survey done by Estonian government about the usage of electric cars, and we compared it with real data, where we basically got an example that what people said, or what they thought, and what they believed, and what was the actual result. What they thought and what actually happened, because we also had the data. And for example, you could see if the question was how frequent did you use the car, you have the data in the car log also. And you can easily convert it in a similar way which the survey was done, completely independently, by the way. So you can basically use big data to validate or to compare with the original surveys. We had tons of questions, like 20 or 30 questions. Another example is just that, what people think is the actual range of electric car and what is the actual range of their electric cars. And it's very good to know then, what they thought and what was the actual result. Lessons learned. Number 1, that the question of what should the results of a big data project be is a tough one. It's a non-trivial question. It's because it's, people not often think about it, but does it have to be like a document or a software or already an action or a presentation? And it's not an easy question. So you should always definitely think about the answer of this question. How do you want the results? Well, maybe it has to be a software where the customer can interact with a solution, but then who maintains it, how long, and so on. Second lesson, students bring creativity. So as I said, it would have been easier if we'd done it ourselves, but we had to use the students' hands. So they learned also on the way of the process. Lesson number 3, things have to look good. So instead of just giving the tables, we put extra effort to having infographics, information graphics, so that basically some person who was just so much into art was thinking about how, if you have this or another kind of data, how you could actually visualize it in a way that it's the easiest, and so that all the insights can be taken from the picture as fast as possible. And a final lesson, that one thing leads to another. We got excellent coverage by media. For example, Arte TV made broadcast a short profile about our research to French, German market. We were in a Fraunhofer case study. Just because of this project, we also were able to participate in a project for Japanese Ministry of Economy, Trade and Industry, which was actually the report. And remember my question, what should the report look like? The report had to be in Japanese. But of course, we were the subcontractors of Mitsubishi Corporation. And this was just because we knew that we could deliver with our previous project. And of course, last but not least is you. So you can think how you could use those kinds of methods with your problems, and how we could collaborate. And with that, I thank you all.
So thanks to Innar, and again, the floor is yours. Like Innar said, you have to do the stuff now. All right, any questions? Yes. Can we get a mic? Okay, yeah, you start and then you.
Oh, hi.
So, well, nice to see you.
Nice to see you.
The point is that I would like to ask, do you have any information about Mitsubishi company in the sense that did they use your results? I mean, those calculated patterns for decision making in the company?
Well, first element, of course, is that the contract is confidential. However, I can say that they do similar research like we did in most of countries. So typically large consultancies do that for them, but we had this extra innovation component. So I think that the main part what we did in the project, they used, and they could compare, but I think they got great ideas how they could, move forward, or what else could they do with the data. So that's a question away.
And the second
And
question?
another question is just that related to the first one, that what do you think about Estonian government bodies or Estonian companies? Can they use those patterns?
Well, I think the main stakeholder or the owner of governmental fleet should definitely be interested in looking into, having this big picture, how our cars or our assets are currently used. So that's the fundamental issue. Of course, another issue is that all those cars are on sale currently from Ministry of Social Affairs. So it's maybe that the timing is not best for that. But yes, they can. Of course, they could have some overview what their people are doing.
And another question?
No, thanks a lot. That's a very interesting project. I find it interesting that you kept an exclusive, use of the data. You kept control of the data, and I guess maybe one of the reasons is privacy because it's raw data. But I don't know. I mean, I feel it's a little bit in contradiction with this, open data philosophy. You concluded your presentation saying you, but at the end of the day, I mean, it's you that you have the data.
So we don't own the data. That's the first answer. We know how to apply the methods. But second answer would be that we did not have the exclusive access to the data. Just the data was not available for foreign entities, but all academic institutions and research institutions in Estonia could have made the deal and could have, and actually had access to that.
But why it is so? Because, I mean, we are in Europe and you would like to have, not even in Europe, but globally, you want to collaborate with any, academic institution or research center in order to exploit the data set, as much, to the maximum extent. So
I think it's a fair question, but maybe the idea was that then you have to collaborate with us. It's like positive thing for us. And another example which I would bring is take like wood as a raw material. Yeah. So basically the policy for data was that we will not give out, the wood material, but just tell us what you want and we will build. So that was we wanted to keep the value-added component in Estonia.
But it's fair to say that there is a trade-off. That's what you're saying, right?
Of course.
To keep the incentive to research. So it somehow is a critique to the open data philosophy in a certain sense, right? Okay.
Thank you.
Thanks.